This is a voluntary seismic retrofit project. We're going to be upgrading it, adding a footing. We're going to be drilling in some 18-inch piers, 14 feet deep into the ground. We're also going to be doing some seismic retrofit underneath the house, where we're going to be adding strapping and sheeting to the stem walls. We live in California, in the Bay Area, where there's a lot of earthquakes, a lot of movement. Plus, this property is on a hillside, so what it's going to do is just help keep everything more rigid and be able to allow the house to move without falling down. This is a 3-story property, so we wanted to build this support to hold the load. There's a lot of weight. There's 2 more levels upstairs, so this is to hold all of the pressure. So when we demo the existing foundation, this is going to provide support so things don't fall. Since the existing foundation has no waterproofing, the existing stucco has no waterproofing, there's no weep screeds, no way for water to come out, we're afraid that there may be dry rot on the exterior wall. So the foundation is just a slab on the first level, and it was just dirt, sitting on dirt. So what we're gonna be doing is pouring a 3-foot foundation here along with a big 24-inch footing to create more support to stop the house from continuing to sink forward. As you can see, the house is built on a hill, and we're having, what's going on is all the dirt is starting to slide forward. It basically compromises the staircase, the structure. So what we're doing is we're building a new concrete wall with 2 footings that this wall is going to be connected to. These footings, 24-inch footings, and they go down about 14 feet deep in the ground, tied into the new rebar wall, which we're going to build a form, and we're going to pour a full concrete wall. So when you see this later, it's going to be just smooth. But we got the wooden dowels coming out to support our form. Well, what we did inside of here, we basically demoed this entire inside wall. We exposed the existing framing. Since the foundation in the inside is like 10 inches, we basically had to, there's plywood under this wall, which is now a structural wall, but we also had to fur this wall out to cover up the foundation block in order to make this wall look like an interior wall and not have the concrete visible. We reused the old windows, but just re-trimmed them out, installed new flashing. On the exterior, we did new Z-bar, new things like that, installed new window jamb, new window trim, just to make everything look new and improved. So why we put up the plywood, biggest reason is this is a structural shear wall now. And since this house is built on a hillside, the customer wanted to add as much as support to the existing house. So what we did is we installed new anchor bolts every 3 feet into the mud sill with new 3x3 square washers. After that, we installed A35 clips inside of the stud bays to tie in the wall to the ceiling framing, and after that we covered it with a 1/2-inch CDX plywood and went ahead and nailed it off in order for it to be a shear wall. So that's pretty much what we did here. So this is going to help the house from wiggling back and forth. Basically what we did is we dug everything out right here. We poured a form. We had multiple inspections, built a rebar cage, attached our rebar cage into the existing concrete slab. We found old brick underneath the house, found so much dry rot. So basically ripped everything out, poured in our new slab, added in the proper flashing, added in new weep screed so water can now drain out. We stuccoed this entire wall, and what we like to do for every one of our stucco jobs is we like to install acrylic finish coat. So this is all finished off with an acrylic finish texture coat with the color. These are some of the things that we had to rebuild, reframe all of this. New drainage system attached into the new storm drains. Yeah.